We're now going to talk about angle relationships in section 11.5. So the first thing we're going to do is we're actually going to start with our first angle. You're going to learn a whole bunch of angles, and actually you're going to learn 5, 6, 7 different types of special angles and how they're related. So make sure you keep good notes and you pay attention. This is what's called a tangent chord angle. And it's called a tangent chord angle because you have a tangent and a chord. Pretty easy. So tangent, chord. Now you'll notice that the vertex is on the circle. That's important. On the circle. So if you have a tangent and chord that intersect on a circle, which is the point of tangency, then the measure of the angle is half the measure of the arc. So in this problem, we have a tangent, and I call it chord even though this is a secant. We have chord AB. And we would know that this angle ABC, its measure, would be half of the measure of the arc, which is ABC. It's just like an inscribed angle, the same formula. So example number 1, using tangent-secant and tangent chord angles. Now, once again, I'm just going to call it tangent chord because even though there's a secant there, it's still a chord. And the reason is because we're going to call another one secant tangent, and I don't want you to get confused. So tangent chord. The measure of angle BCD. Well, if the arc is 142, BCD is a half of that, so the measure of angle BCD is 71 degrees. So now we want to find the measure of arc ABC. Well, we know the tangent and the chord that make that up is 90 degrees. So that means the arc is double that. So the measure of arc ABC would be 180 degrees. Pretty easy. The next theorem, 11.5.1, talks about a chord-chord angle. And the reason it's a chord-chord angle is because you have two chords that intersect. Notice that the vertex is on the inside of a circle. That's just like a central angle, but it doesn't cross at the center. So if two chords intersect in the interior of a circle, then the measure of each angle is half the sum of its intercepted arcs. So what you would do is, in order to find the measure of angle 1, or its vertical angle, you would add the two arcs together. So you would add the measure of arc AB and the measure of arc CD, and then you take half of that. And in example 2, we'll prove that. Find each angle measure. So angle SQR is what we're going to find first, SQR. So we want to find this angle. All you would do is, to find the measure of angle SQR, you would add up the sum of 32 and 100, and you'd take half. So the measure of angle SQR would be a half of 132, which would be 66 degrees. That's it. In Theorem 11.5.3, we're going to talk about 3 types of angles. Now, notice the vertex here. Where's the vertex in all these angles? On the outside of the circle. So we're going to talk about the secant-tangent angle, because you have a secant and a tangent. You have the tangent-tangent angle. And you have the secant-secant angle. So tangent and a secant, 2 tangents, and 2 secants. All of these are the same. When you intersect on the exterior of an angle, then the measure of the angle is formed is half the difference of the two arcs. So here you would take arc AD minus arc BD, you take half. Arcs EG and EG, or actually EHG minus EG, you take half. The measure of arc JN subtracted by the measure of arc KM, and you take half. So if we found the values of x on both of these, x degrees would equal 1/2 the difference of 174 and 98. So you take 174 minus 98 degrees would give you 76 degrees. And then half of 76 degrees would be 38 degrees. So x would be 38, which makes the angle measure 38 degrees. In B, we know we want to find x. But wait a minute, we're not given arc EHG. What is it? Well, remember, this is 32 degrees. The whole thing has to add up to 360. So 360 minus 132 gives me 228 degrees. Subtracted by a 132, that's going to give me 48 degrees. So x will be 48 degrees. So in this problem, example 4, it says that when a person is farsighted, light rays enter the eye and are focused behind the retina. In the eye shown, light rays converge at R. If arc, the measure of arc PS, is 60 degrees, and QT is 14 degrees, what's the measure of angle R? Well, the measure of angle R would be 1/2 the difference. Well, 60 minus 14 is 46. So the measure of angle R would be 23 degrees. So here's our review on all of them. If they're on a circle, if the vertex is on a circle, like an inscribed angle and a tangent chord angle, you take half of the measure of the intercepted arc. Inside a circle, you take half the sum of the measures of the intersected arcs, and the outside of the circle, you take half the difference of the measures of its intercepted arcs. Here are the examples of all 7 angles that you've now found up to date. These two are when the vertex is at the center and inside. Here we have vertex on the circle, and here we have vertex outside the circle. There's no really new vocab, but you need to know what all the angles are and how to find them.